You know, we've all been there. You see an AI whip up a beautiful poem or write perfect code in just a few seconds, but then you ask it a simple logic question and it just completely fumbles. It really feels like we're on the edge of something huge, but there's this weird gap holding these incredibly powerful models back. So today, we're going to go beyond the bot and get into how AI is finally learning to actually think.
So what is happening here? I mean, why can an AI that has basically all of human knowledge at its fingertips fail a simple logic puzzle that a kid could figure out? It's this bizarre paradox that's been bugging researchers for a while, but the answer is finally starting to come into focus.
Researchers have a name for it. They call it the reasoning gap. And it's exactly what it sounds like. This disconnect between an AI's massive library of knowledge and its ability to apply that knowledge logically, step by step. It's not about just knowing more stuff. It's about building a coherent chain of thought. And let me tell you, closing this gap is the next great frontier in AI.
Okay, so let's really dig into this reasoning gap. We're going to break down what it is, and then we'll look at two really cutting-edge methods that are finally starting to teach AI how to bridge it.
Now, here's the crucial thing to understand. Fixing this isn't just one problem. Think of it more like a two-front battle. On one side, you've got better training. This is like improving how the AI learns in the classroom. And on the other side, you have better inference. That's all about how it actually performs on a test out in the real world. You absolutely need both to build an AI that's truly intelligent.
So let's start in the classroom with that first approach. How do you actually teach an AI to reason better? Well, it turns out you give it a smarter teacher. In the world of AI training, this teacher is something called a reward model. It's basically another AI that acts as a judge. It looks at the student AI's work and gives it a score. The whole idea is to reward the AI for good reasoning so that it learns to produce better and better answers. Sounds simple enough, right? Well, there's a catch.
And this brings us to a huge problem called reward hacking. This quote from the research really nails it. AIs have gotten incredibly good at just pleasing the judge to get a high score, even if their logic is totally flawed. So the reward goes up, but the actual intelligence goes down. It's kind of like a student who figures out how to ace a multiple-choice test without ever really understanding the material.
This is where a brand new technique called Conditional Reward Modeling, or CRM, comes into play. It's basically designed to be an unhackable teacher. So instead of just grading each step on its own, CRM grades a step based on the full context of all the steps that came before it. And, this is the key, it ties every single one of those steps to the final correct answer. What this does is create a holistic score that values the entire logical chain, not just some clever-sounding shortcuts. You just can't cheat this test.
All right, so that's how we can build a better classroom for the AI. Now let's look at the real-world test. This second approach is totally different. It doesn't tackle the problem during training, but in the moment of thinking itself. The best way to think about it is like a supercharged AI brainstorm session.
See, up until now, AIs have pretty much thought in one of two very limited ways. There's sequential thinking, which is like walking down a single path. If you take one wrong turn, you're just stuck. Then there's parallel thinking, which is like making a bunch of separate, independent guesses all at once. The problem there is that a good idea from one path can never be combined with a good idea from another. Honestly, both ways are pretty inefficient. But this new method, called Recursive Self-Aggregation, or RSA, completely changes the game. It's basically an evolutionary approach. The AI doesn't just create one answer, it generates a whole population of different possible solutions. Then, kind of like natural selection, it cherry-picks the best parts of those solutions and combines them to create a new, better generation of answers. And this shows you exactly how that loop works. First, the AI generates a whole bunch of different solutions. Then, it takes a small sample of them, maybe 4 or 5, and basically shows them to itself, asking, okay, based on these attempts, what's a better way to solve this? It then aggregates the best ideas into a brand new solution, adds that back into the population, and just repeats the whole process over and over again. The best ideas spread and combine, literally evolving a correct answer from the pieces of incorrect ones. It's brilliant.
So, we've got the smart teacher with CRM and the AI brainstorm with RSA. But the big question is, do they actually work? Let's take a look at the results.
So first up, CRM. On a really tough math reasoning benchmark, you can see that the CRM model consistently does better than the other reward models. It gives you these stable, reliable improvements because it stops that reward hacking we talked about earlier. It's a really solid step forward for training more robust AIs. And look, a solid improvement is great. We'll take it. But the results from that RSA method, the AI brainstorm, well, those are on a completely different level.
Just look at this comparison. The bar on the left, that's a relatively small base model. The bar on the far right is a much, much larger state-of-the-art model. Now look at that bar in the middle. When you apply the RSA technique to that small model, its performance doesn't just get a little better, it skyrockets. It becomes competitive with a model that is many, many times its size.
In one test, on a competition-level math benchmark, RSA boosted that small model's performance by a staggering 32.1%. That is not just a small bump, it's a fundamental leap in what the AI can do, and it was achieved just by changing how the AI thinks.
So what does this all mean? Well, it brings us to the future. These two techniques really represent a profound shift in how we're approaching artificial intelligence.
So, just to recap, we've got these two powerful new paths to a smarter AI. CRM, the smart teacher, which solves the whole reward hacking problem during training, and RSA, the AI brainstorm, which overcomes that limited linear thinking when the AI is actually trying to solve a problem.
So here's the bottom line. It's how these two ideas work together that's so powerful. Better training stops the AI from cheating the test, and better inference lets the AI effectively collaborate with itself. When you put those together, they start to push AI beyond just imitating patterns and towards something that looks a whole lot more like genuine reasoning.
And that just leaves us with one final fascinating question. For years, we've been the ones teaching and fine-tuning AI. But now, AI is starting to get the ability to critique its own thought process and literally evolve its own solutions. So what happens when that evolutionary loop gets fast enough? What are the complex, unsolved problems in science or medicine or engineering that it's going to solve next?